In this segment, I'm going to talk about some basic graphing skills. We're going to start off with the idea around number lines. Then I'm going to move on to the Cartesian graphing system and the production of ordered pairs or coordinates in that Cartesian system. So here I'm starting off with a number line. My number line starts here at 0, and I'm going to be moving this point A relative to that number line point at 0. And I'm going to have the computer over here tell us how far away from that 0 I am. So if I can just click on here and drag, I can see there I am about 1. Now I'm over here at 2, 3, 4, 5. And if I go all the way back, I'm here at 0. And I can get the computer to tell me how far away from the 0 I am. And this is how my number line works. And I can change the size of my number line if I like, and then the grid pattern. And so now I can see that my tick marks are smaller, and so there I am at 1 there, 2, 3, 4, 5. So I can vary the scale of my number line. It starts at 0, equal size ticks, and equal value for each tick. And I can change that scale if I like, just by going here and telling the computer to change that scale to whatever way that I'd like to change it. And so I can say this is at 1, 2, 3 ticks away from the 0. So my number line is talking about the distance away from the 0, and if I move over to the left of it, we get into our integers, and so now I'm talking about in the negative direction, -1, -2, -3, -4, -5. And students are familiar with the number line. They start off with 1 starting at 0, it grows to the 1 starting with including the negatives, and we just have to worry about one value, how far over, left or right, across, back and forth, across the number line. We could say, what is the run or the across value? I've run 1, 2, 3 over from my starting point. And we need to have a starting point. And everything is relative to that 0 point on my number line. But what happens if I have a point up above? So I've got my computer doing this so that when I drag this, I have a point that also moves. And I'm going to ask the computer, please tell me what is its value away from this starting point for this point here. And we can see as my A value moves, so does my value for B, because it is the same distance away from where I start. Now, where is it that I'm measuring from? So on this question here, when I had just the A dot, then I can see that I'm measuring from my 0 point. But where am I measuring for this dot up here? Am I measuring from here, which is a much longer distance? Where am I measuring from? It's important for students to realize that on a number line I have a dot here or a tick mark for my 0, but I can extend that straight up and down in a perpendicular line. And so my distance from B, as I'm measuring here, as I drag this across, my B gives me the same value because it's the same distance from this line here, my starting line. My starting line is my y-axis. And this confuses students sometimes. If I'm talking about the x value, why am I measuring from the y-axis? Well, my x value, so how far over am I going? And my y equaling 0 is my starting point. So when I say 0 here on my number line, it's also 0 here on my number line up as well. And so any distance left or right is left or right of the y-axis. In this question, I've taken my number line. Instead of having a horizontal number line, I've got a vertical number line. So if I grab my B point, I want to find how far away from my 0 it is. So here I am at 1, here I am at 2, 3, 4, and if I go below that, I'm at -1, -2, -3, -4. So this distance here that I'm measuring is how far up my number line I'm going. Again, I can show another point and say where is this point relative to my starting point. And so as this one moves up, it also moves up, and as it moves down, it also moves down. So it should have the same value. So I'm going to have the computer measure that, and we can see that they are the same. So as I drag B down towards, they both come down to the 0, and as they go below, they both go into negative numbers. So it's relative to this starting point right here at the 0. Again, as I move up, this one is not measuring from the distance diagonally to this, it's measuring the distance up and down from a starting point. That starting point is the x-axis. So we can see that both B and C is measuring the distance away from this starting line that goes horizontal. Another name for that line is the x-axis. And if I show the line here that I've got, we can see that these are parallel lines. And what I'm measuring is how far above the black line is the blue line. How far below the black line is the blue line. And each of these points tells me how far down or below. So I can have a number line that's a horizontal number line that's measuring how far away from the y-axis it is. And I can have a number line that's vertical that talks about how far from the x-axis I am. And so that's often confusing for students. But when we draw it this way, how far above the black line is the blue line, then it's quite easy to see. No matter where I put my point, over here on that line, measure the distance please for the y value, and we can get that it's the same distance every time. Any point on this line, if I move this line, always gives me the same number because they're the same distance above the x-axis. If I put those two ideas together, I end up producing this kind of a chart or grid or graph known as the Cartesian plane. And rumor has it, a gentleman by the name of Descartes, when he was very young, he was very sick and he spent a lot of time in his bed. And he spent time looking up at his ceiling, and he was saying, if I have my fly over here at point A, how would I describe it to someone as to where that fly was on my ceiling? I'd have to have some kind of over amount and some kind of up amount to describe it. And you'd all have to start from a point where everyone would agree would be our starting point. And if I had my picture looking like this, where my starting point was way over here in the bottom left-hand corner, then all I would be getting are positive numbers. I'm over to the right, and these are all positive numbers. So my over numbers up here we can see. My over numbers keep changing as I move over, and they're all positive numbers because I don't have anything on the left hand side of that line there. And if I pick my up numbers, when I'm talking about this, my up number goes up and there's no negatives. If however my starting point needs to have, I need to have some negatives, if I'm talking about things like temperature, it's going below, or time, which is happening before where I am now, I need to have some negatives, so I'd have to move this starting point over someplace. Let's say something like this, and now everything would be termed relative to that starting point. I'm over 1, 2, 3, and so my over number is about 3 there, and I'm up 1, and so I have an over and an up value. And apparently rumor has it that Descartes, when he was a very young child, came up with this idea of measuring space in a two-dimensional space, which would require two dimensions, two measurements, one in one direction, the over, and the other one in the up. And we call those coordinates or ordered pairs. And so we always write it in the following manner, with a bracket, a parentheses with a comma separating the two of them. They're always in the same order. The over number is always first and the up number is always second. If they were reversed, I would be confused. If I wanted to go, if I said 3.07 was my up number and my over number was 2 point something, then it would be over here as opposed to over 3.7 and up. So I have two different locations with the same numbers. Let me see if I can demonstrate that a little better for you. So here are 2 points. A is at 2.99 and 1, so about 3 and 1, and B is at about 1 and 3. So they're at two very different locations. And if everyone doesn't agree that they're going to be in the same order, there could be some major confusion. If you had to place a mark on a wall, or if you had to pretend this was aiming something at a target, the targets are in very different places. One's going to hit and one's going to miss. So we all have to agree what order we're going to put them in. So the order that we agree on is the over number is always first and the up number is always second. Now instead of calling them the over and the up, we go back to my original picture that I had here with my number line, when we did it first, our first number that most people are familiar with is the number line that talks about how far over it is, over from this starting 0 point on my number line or the y-axis. So my first number is always how far over it is, and the second number, if we went back here, is talking about moving it up and down. And so we talked about our number lines in that order. The first one was talking about our regular number line across our number line horizontal that we normally draw. And the second number line was talking about moving things up and down. So that was our y value. We put the two of them together now. Our first number tells me how over, 1, 2, 3, and the second number tells me how far up. So x value and our y value is the order that we always place them. The over value, comma, then the up value. And if we have negative numbers, my over value would be a negative, but my up value is still up above, so it's a positive value. So my value is at -1 approximately. It's to the left of my y-axis, but it's still up, so it's a +1. If it was down here, I'm to the left, so I have a negative over value, which is -1.03, and I'm also below the line, so I have to have a -1.83. So talking about Descartes' method of finding a location in 2 dimensions, we need 2 numbers, one for the over and one for the up. It's just a matter of combining 2 number lines together and making sure that we always put them in the order of the over number, the x value, and the y value, the up number. I'm briefly going to talk about the idea of something called the intercepts, which is a term that you hear in high school. I often mention to students, if I was throwing a pass and I wanted to pass it from the starting point to point A, if someone came across and caught it, that would be called an interception. So coming across means interception or intercept. So I'm going to take a look at this point here at A. If it crosses the x-axis some point, it's always going to have a y value of 0 because it's not above the line. It doesn't matter where I cross it, here, 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 over here, I always end up getting a y value of almost 0, and if I'm right on the line it would be exactly 0. So my x-intercept, where it crosses the x-axis, my y value is always 0. And there it is, the x-intercept, where it crosses the x-axis. The y value, my up value, is always 0 because it's never going up. It's right on this line. So that no matter where I put it, right on this line, it's always about a 0. And if I was accurate, it'd be exactly on the 0. If my a value, if my point comes across and comes closer and closer and closer to the y value, what happens here? Well, my over value now becomes 0 because I'm not going left or right of that. I'm right on that line. So no matter where I am, where it crosses this line, notice my x value, if it crosses down here, my x value is always going to be 0. So when I take my a value, anytime it crosses this y-axis, I'm end up going to get an x value of 0 because the over value is always going to be 0. So these are known as the intercepts, and this is an important fact for high school students to understand and use those terms properly.